So this talk is called How Do I Content Security Policy, which my children told me is bad grammar. What we're going to cover today is we're going to do a little exercise, not physical, don't worry, and then we're going to do some light reading. So for the exercise, grab a bit of paper and roll it into 6 columns. Make the second column a bit bigger. If you don't have paper, then feel free to just type them onto your phone or something like that on a spreadsheet. Paper is this thing, like back in the old days, we used to have these things called trees, and we'd chop them down and roll them out into flat things. Then we'd write once on them and then throw it away. Cool. So in the second column, I want you to list out all the sites that you have. Don't worry, this isn't a test. If you forget some, it's fine. But all the sites, all the applications, everything that your company has. Yeah, one piece of paper might not be enough for some companies. But yeah, just the top ones that come to mind. Cool. So I'm going to assume you've done that, and everyone's going to nod and play along, even though I see lots of people don't have bits of paper. So put a tick next to the ones that you have to log in to access. So in my example, I've got to log in to get to the internal finance app, and I've got to log in, customers can log in and buy things from our shop. And in the fourth column, put a tick if there's anything sensitive in that system. So maybe internal systems that don't require like login, maybe they still have sensitive information, or maybe stuff that has logins that's not that sensitive, like our finance app is way more important than our shop. Cool, and then next step is to rank them in importance. So looking at those sites that you've written down, which ones are the most important to you? Which ones do you want to protect the most? And you'll probably see the stuff that has sensitive data is going to be near the top of your ranking. And you know, normally stuff that has login is also a bit more sensitive than stuff you're open to the world. And these are the things that you're probably most worried about for cross-site scripting, because cross-site scripting might happen on your marketing page or your blog. That might be embarrassing, but there's no data that can leak. If no one's using that site with a cookie, then the JavaScript running in the cross-site scripting has nothing to access. It cannot snuff data off the site. Cool, and then in the last 2 columns, put ticks whether you've got source code for those apps. So we've got the WordPress source code, but we don't actively develop it for our blog. And whether you actively develop that site or not. And this is going to kind of be useful a bit later. So, you know, some systems that you have might be proprietary. You don't have any ability to modify them if there's any issues. You might have the source code for something, but no one's worked on it for 3 years. If there was an emergency, you wouldn't be able to do anything anyway. Cool, okay. Put that piece of paper to one side, and now it's reading time. Put up your hand if you've ever read a Choose Your Own Adventure or a Pick a Path book. This is awesome. There's lots of old people here. I brought this up in the office, and I'm an old person, so hopefully I didn't offend you. And someone was like, what are they? And I was like, well, before you had hyperlinks and the internet, you would read a book, and to choose your own adventure at the bottom of the page, you'd get some choices, and you could flip to a page depending on your choice. So it's kind of like a game. And the cool thing was you'd get a 200-page book, but you'd only have to read 40 pages because all the other ones were the other possible endings, which were invariably you have died a horrible death. And the other thing that was fun about these books is you'd be worried that you were going to die, so you'd put a finger before you made a decision, and then you'd turn to page 37, and if you died, you'd go back to that finger. But sometimes you weren't sure about page 40 whether you were going to die when you went to the next one, so you put your other finger in as well. And so if you'd be reading a book with your hands twisted like this, and yeah. Cool, anyway, so we're going to do a Choose Your Own Adventure, and we're going to talk about cross-site scripting. So I'm going to kind of assume you know what cross-site scripting is, but we'll cover that briefly, so don't freak out if you don't. This was the standard warning at the front of the Choose Your Own Adventure books. You and you alone are in charge of what happens in this story. Don't despair, you can go back and change it. It's kind of like life, really, isn't it? Okay, you're a web developer. 1995, someone invented JavaScript. They called it Mocha script. And then sometime after that, cross-site scripting was invented. And it didn't get a name until 2000s-ish. But people were attacking websites by abusing JavaScript pretty much as soon as it was made. So do we understand cross-site scripting? We can skip to page 19, or if we don't understand, we should jump to page 15. I'll just quickly jump there for those people that aren't that comfortable. So what is cross-site scripting? Well, it's a bug that's everywhere. Google pays out millions of dollars a year for bugs in their own software, and they're probably some of the most secure web applications out there, consumer-facing. But 60% of their bug payouts are cross-site scripting. Bug crowd bounty hunters, 20% of what they find is cross-site scripting. In my experience, almost all sites have cross-site scripting. There is nothing to back that up. And the deal is that cross-site scripting, or the JavaScript that's infected, can do anything that your users can do. So if a user's logged into the finance app, an attacker gets them to run JavaScript, it can do whatever the user can do. So transfer money, I don't know, change salaries, whatever. It can crawl the whole site. It can do anything. Oh, go to page 16. Cool. And how does cross-site scripting work? Well, basically it's because of this fundamental problem with Tim Berners-Lee and his invention is that he mixed code and data into the same blob of characters. An HTML page, you've probably seen one of these before. This might not be the right conference if you haven't, but we'll go with it anyway. HTML page has, it has semantic stuff and it has content like the word hello, and then it has code, which is the JavaScript there setting an urchin ID, whatever that is. And it's all jumbled in the same page, and when you give that to a web browser, it doesn't know whether to run that code or not, because it doesn't know if the website gave it the code or if an attacker injected it in, and most web browsers just go YOLO and just run it. And so that's kind of the basic problem with cross-site scripting. So here's an example. Someone enters their name, and they were brought up in a strange household, and that's their legal name. And then when it's output into the page, and someone views the page of young script alert, the JavaScript runs, and obviously that JavaScript can do anything. Cool, and then the complicating thing, I guess, as well, is that in cross-site scripting, well, when you're outputting data into your web page, you have to think about where you're outputting it and make sure that you escape it correctly for whichever context it's in. So the legal characters of a name in an HTML element are different than the legal characters you can put into an attribute. Obviously you can put double quotes here and you can't here. You can put angle brackets here and you can't there. And the same for URL queries. You have to put %20 or whatever for space or plus or whatever. And CSS has different rules, and JavaScript has different rules. And when you're assembling your web page, you can have a JavaScript block inside an HTML element, or HTML elements inside JavaScript blocks, or CSS things, and these things nest, and it's insane. And when you're the developer, you have to try and think, well, I want to put this person's name there. Do I need to do HTML encoding or attribute encoding or whatever? So that was cross-site scripting. So now do you understand cross-site scripting? I'm going to say yes and pretend that was a really good explanation. So now the thing we have to do is figure out how we're going to fix it. And there's basically two ways. You either fix it when you display the data by encoding it to make it safe, or you fix it when you're receiving the data and strip out anything that's dangerous. And normally the advice is to do it on output, because when you receive data, you don't know what you're going to use it for, so you don't know which one of these different contexts you need to make the data safe for. If you've still got XSS that you need to fix in your applications, then I would say go to page 20 and just keep on fixing your applications. Not all browsers support content security policies, so you still need to fix everything that you know about. But once you're finished fixing once you're finished fixing all your cross-site scripting, then content security policy might be for you. So a little diversion to talk about a defensive mindset. This is a castle. Let's pretend the Queen Elizabeth II lives in that window there. That's her bedroom or whatever. I imagine she probably lives in castles. And you want to protect her. And what the designers of the castle have done is they've put multiple layers of defense to protect her. So, they've got a staircase with a guard at the bottom. They've got a big open courtyard where archers can fire at the attackers if they cross it. They've got one of those metal things that drops down and chops people in half in movies or whatever in the doorway. And they've got a moat around the edge. And, none of these is perfect. None of these defenses is perfect. The moat is only protected against 16th century people that can't swim. And anyone else can get across it. The courtyard is good defense in daylight, but not so great at night when you can't see people crossing it. And that's kind of how we work in security as well. There's no perfect defense for anything. What we're doing is layering defenses on top of each other until the attackers give up and go away. And depending on how much you're targeted, you might get away with less layers. And the reason I bring this up now is that content security policy is not perfect. It's not a perfect defense for cross-site scripting. I think Google said it was 75% of the XSS bugs that they find could be fixed with content security policy, and 25% can't. So that's, I guess, that. Okay, next page. Okay, you're ready. Okay, you're ready for the adventure of a lifetime. I might be slightly overselling this talk. So I guess we should vote on whether we should learn about it or whether we should stop now. Yeah, okay, no, we won't vote on that. Okay, so the goal of content security policy, it actually covers more than cross-site scripting, but I'm just focusing on cross-site scripting because that is the prevalent attack that it addresses, and all the other stuff is actually harder to do in content security policy. The goal is to prevent unwanted scripts or untrusted scripts from running. And how do you do it? Well, basically, you separate your code from your data, like we should do anyway. Most other systems separate code from data, just not web pages. And specifically, you're separating your code, the ones you want to run in the user's browser, from the attacker's data, so they don't mix up. And so the attacker can't put code in that runs. And how you do this is you set an HTTP header. So every page that you return from your web server to the browser, you set this header, and then the browser follows the instructions, which are basically telling it which bits are legitimate code to run. Unfortunately, to get the maximum benefit, you're probably going to need to modify your application. And that's why we did that little exercise. When I say we, I mean like the one person who did it. And looked at which systems we had source code for and which ones we were able to do active development on. Because there's two ways you can do content security policy, and there's kind of like the average-ish way, and then there's the slightly better way. I'm going to cover both of them. But the average-ish way kind of works better. If you don't have the source code, you can still do stuff the average-ish way. Cool, I'll explain that more as we go. Okay, so we're building a brand new project. We have the source code on an active development team, or you don't have that. Okay, let's do that one first. So the first approach, if you don't have the source code, is to use this URL whitelist approach. So you set a content security policy header like that one that I've got there, and it specifies which URLs are allowed to provide JavaScript to this web page that's loading in the browser. So in this example, the browser will read the policy and only run JavaScript that's from the current website and google.com. Seems pretty straightforward. Let's drill into that. So there's a couple of things on there. So script source whitelists. My Choose Your Own Adventure will be available for download from the OWASP website. So yeah, published author. put that on my CV. So let's talk about script source first. So this is kind of the meaty bit about using a whitelist approach. What you're doing is listing out all the places that the browser is allowed to load script from. And there's a few different types of sources you can put there. You can put a host name like google.com, an IP address like the 1840s. You can put wildcards in there. You can put HTTPS and your host name, or HTTP:87 or whatever if you're running on a weird port. So host names. If you want to be a bit more relaxed, you can just put schemes and say, my website's allowed to load any JavaScript from HTTP websites. Don't do that, just a hint. Self, which is the current website. None, which means don't run any JavaScript on my page ever. And then two other options, which we're not going to talk about right now because they're evil. And the problem is when you've got an old application, it's really hard to figure out which websites it loads JavaScript from. And you probably think that's a weird problem to have, but if you look at that list of websites you've got, is there anybody in this room that could honestly say they know where all the JavaScript of those websites comes from? Okay, you're lying. No, just kidding. No, it's really hard. And of course the thing is, even if you include Google Analytics, what domain name is that on? Analytics.google.com, I think, /GA. I don't know. Even if you include that, there's no guarantee that ga.js isn't loading JavaScript onto your page from google-analytics.com, which isn't loading more JavaScript from something else.com. And so you don't really have any way of knowing unless you can control the whole ecosystem. But there is help. Content security policy has this report-only header. So the normal header was content security policy, but if you put -report only, it doesn't affect the users of your website. It doesn't block them. It doesn't do anything. But it can send you reports to a URL for every violation on your page. And I'll show you what that looks like. And it reports every time a script or a plugin or whatever on your page doesn't meet the policy. So if you'd like to see how this works, go to page 29. Okay. I am showing a paid-for tool, but it has a free version, so we kind of decided that was okay for an OWASP talk. There's probably some open source thing that you can use to collect these as well. So Scott Helms, a speaker and technology guy from the UK, who's got this site, reporturi.com, that used to be free, and it's also got a great domain name that used to be mine. He's made this free product and then worked out he couldn't keep it free forever. So now he charges a graduated amount based on volume. But we only have small volumes when we're building up our policies, so it's still free for us. And it was now the time I was going to do a demo? No. So this is just basically what you do when you're using the product. You create an account. It's got this wizard who has got like a pointy hat. No, it's not that kind of wizard. Where you add a simple header to your website. So here I've just got a header saying don't run any JavaScript and then report it to my URL. So basically, if I browse the website now, every single JavaScript that runs is going to fire to my reporting URL. And you browse around the site for a while and you get these violations. And if you're in your browser, I don't know why that's all pixelated because it's not on my screen, but you know, in that console, JavaScript debugger console, you can see the browser firing off reporting events to the site, and they'll show up in the wizard as sites that you can add to your content security policy. So I'll show you what that looks like since that's so tiny. So basically in here you've got this wizard page, and in here as you browse around your site, it will collect the reports, parse the URLs of the JavaScript that you're inserting, and give you things to choose to add to your policy. So I've added Google Analytics, Google, and gstatic to mine, and we'll ignore that one for now. And other things it does, it'll show you graphs of different types of violations, which are there, and reports and stuff like that. And you can also drill in and look at the individual ones. So on a regular monitor, you don't have to scroll left to right, but we do. So this is my company's marketing site. There's nothing sensitive on there, so I was just playing around on there. So what you get is basically a log of every bit of JavaScript that's been loaded on your site. And you see that there's some weird stuff in there, like a gateway.zscaler. There's eval, and you can open it up and try and figure out what's happening and whether that's legitimate or not. And somewhere in here I saw, and sometimes you'll get examples of what's actually being blocked as well, or would have been blocked if you weren't in reporting mode. So just a brief digression. So it turns out that visitors to your website actually run random JavaScript that you have no idea what it is. And that's really weird. And those people are probably sitting in corporates that are man-in-the-middling all their traffic and inserting crap into their browser. So that would be an example of the Zscaler. So they're inserting, I don't know, gateway.zscaler.net script tags into the RedShield site while their users browse it. And other ones that get inserted is like plugins or browser extensions, or sometimes insert extra JavaScript in. So yeah, when you're looking at this, be prepared for some weirdness. Cool, so anyway, we've browsed around the site and we've collected a list of host names that we think our site gets JavaScript from. And we can build up our whitelist, so we can take those and add them into the middle of our policy. And if you think you haven't browsed the whole site, maybe you can just do it again and just try everything and browse around again. And this is one of those pick a path bits where you go around in a loop. It's quite fun. So you go back there, and then you go there, and then you go back there. Cool. And then once you've browsed your whole site and it's kind of stable, then you can publish the policy for your customers or your website visitors. And you can put it into production, and you can either start off with report-only mode if you're a little bit scared, or you can go the whole hog and go into blocking mode and say, block anything that's not from these domain names. Well, that was where I was supposed to do the demo. And so that's a whitelist-based policy. So we're specifying individual URLs that JavaScript can load from. So why is this useful for cross-site scripting? Well, it means that the only places that can inject script are the ones on our whitelist. Cool. You'll notice here also I put object source none and base URI none. These are two other content security policy flags that affect cross-site scripting. So I'll just show you them briefly. So luckily Flash is dead. And so is Java, and so you don't need to specify any URLs that people on your site are allowed to load Java or Flash from, so you can just stick none there, and if that's not the case, then unfortunately you'll have to put the URLs in. But because Flash and Java applets can both be used for cross-site scripting attacks, you need to block them as well. And for base URI, it turns out there's an attack you can do. If I stop moving my mouse, you'll be able to see it. If someone inserts their first name as base href equals and their site, that means that any resource that loads in the page, instead of loading from your server, will load from attacker.com. So that jQuery URL that you thought you'd put on your web page actually loads jQuery from attacker.com/jQuery. So that's the base attack. So you just need to make sure that you turn that off as well. Cool. Okay, so we've looked at what a whitelist is, looked at how to collect it, made a minimal kind of content security policy. Let's look at some advanced topics. What can go wrong? So this is the bit I said I'd come back to. So there's some entries you don't want to put in your whitelist. So you don't want to allow every HTTP, HTTPS site in the world to have JavaScript on your page, because if someone gets cross-site scripting on your site, they can just point to their own server. And then the same with data URLs, which is when you put all the JavaScript in the link in base64 or whatever. The other thing is unsafe inline, and this is inline script tags like script and then var blah blah blah, and JavaScript colon links and on-click equals. And this is the bit that's painful with content security policy, because an attacker who does an inline script is pretty much the same as you doing an inline script. The browser can't tell the difference. So try and avoid that if you can, but your website, if you can't change the source code, it might be unavoidable. And then the last one is unsafe eval. So unsafe eval in the policy says that JavaScript can eval code, which is normally like you're given some JSON and you're parsing it the eval way, which is evil, instead of doing JSON.parse, or you've got some random thing. It's normally a bad sign. Other things that can go wrong is that you're whitelisting some URLs and saying that they're safe, but do you really trust Google? And do you really trust all the other places that you get your legitimate JavaScript from? And the problem is you don't, because if they have other JavaScript libraries with issues like Angular, or they have endpoints using JSONP, where basically on the URL you can put some JavaScript, and that endpoint at Google Ad Services generates a script tag with, generates a page, generates a script file with that alert 133 in it. Then that's going to allow people to link to JavaScript from your site. So you kind of have to trust these. And in the latest version of CSP, you can put a path. So you can say, load anything from googleanalytics.com/something/something I trust. But that's still not that safe. So a whitelist-based policy isn't really the best kind of content security policy. And it turns out it's quite hard to build one of these for an existing site, but if you can't change the site, this is probably the best you can do. People tend to get hung up on doing whitelist ones as well, because they have to enumerate every possible thing their site uses, and so you use Optimizely. What does Optimizely use? Oh, it inserts script from somewhere else, and what does that use? And you end up with this huge long whitelist. Excuse me, but based on what I was saying before, like, it's better than nothing, because now the attacker at least has to find script on one of those hosts to embed with their cross-site scripting attack. So let's look at the strict way of doing it. So if you're building a brand new project and the world is your oyster, this is the way you should start from the beginning. And this approach has been coined strict CSP by the folks at Google who have used this approach. And when you're starting a new project, pick a templating system that'll let you do this. I'll explain what this is in a sec. Don't write inline event handlers. I think they're kind of out of style now anyway. And don't use eval. And then this is the way to go. So as I was saying, strict CSP is coined by the Google guys. And they tried to implement content security policy on their web applications and found it really hard. And basically wrote a new addition to the spec so that they could do it easily for their apps, and found it easier. They did a talk here 2 years ago, which is a lot more advanced than this talk. So you can go back and look at the recording and see that I've also linked to the stuff, their research on that link. So you just need to click that when you get the PDF. And basically, instead of the whitelist approach, this follows the separate your data from your code approach. So you know how the problem with an HTML page is that it's just code and data mixed together? Well, what you do is you mark which bits of code your web server generated with a thing called a nonce. And so this nonce here is just the number 42, base 64 encoded. Probably you want one that's a little bit more random than that. But when the browser looks at this page, it can go, well, these two bits have the nonce on them, so I'll run that code, and this bit doesn't have a nonce on it that's right, and so I don't run it. So the attacker bits are distinguishable from the bits that you as the web developer have written. This will hopefully make more sense as we go through. So to generate a nonce, you generate a random value of 128 bits or more. The number 42 might not be quite that random. And in your content security policy header, rather than all those host names, you just put the nonce in there. So it's a base 64 encoded random number. So the web server sends that nonce in the header, and then in your web page that you send along with the header, everywhere you have a script tag, you put nonce equals and inject that script, that nonce value in your script. And this is where, if you have a good templating language, hopefully this isn't too painful. So I'll just go back a sec. So now, hopefully that's clear that you've now delineated which are the safe bits of JavaScript on your page and which aren't. And if an attacker gets JavaScript onto your page and it's not in one of these blocks, it's not going to run. Cool, but the downside is that you still have these blocks of code that you have written that you need to make sure are safe. So lib.js that you wrote, you have to make sure that doesn't have any XSS in it. And this script tag where you're doing foo, you have to make sure that foo's safe, or any data that foo accesses is safe. And so this is where that 25% of bypasses that Google had, 75% of their apps are safe from cross-site scripting. Sorry, what was it? I got that stat around the wrong way. Of the cross-site scripting attacks that were found, 75% were stopped by content security policy, and the 25 that weren't is when it's inside your code, basically. So you have to make sure that stuff's safe. And then the other thing you have to worry about is if your JavaScript library lib inserts other JavaScript libraries, which is a kind of a common pattern these days to have, like JavaScript loaders, or do you call them bootloaders? Loaders? Something like that, where you have your lib and it loads jQuery and blah, 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 as separate URLs. So if you do that, then you'll want to go to page 42. And this is the bit that the Google guys came up with and put into CSP3, which is called strict dynamic. And what this means is if you put a script tag on your page with a nonce, anything that script then loads is also counted as safe. So your lib.js is safe, and anything that lib.js loads is also safe. That's essentially what strict dynamic means. I'm not going to go into all the nuances of strict dynamic, but the Google guys have a good site that you can go and have a look at, and you will have a fun time. It's only about 5 pages to read. And like the whitelist-based approach, you need to get rid of all your inline event handlers. And so if you're an old-school 90s JavaScript developer like me, you probably do href equals JavaScript : blah, blah, blah. That's what we used to do in the good old days. We just used to shove some JavaScript in between an on-click or an on error. But these days, you have to do it this way. So you separate your script from your markup, and you attach an event lister. So attach an event lister to your A tag. If you do JavaScript, this will probably be a pretty familiar pattern. I think this is more the standard way of doing it these days. And once you've got rid of your inline handlers and you've got your strict content security policy, then you're at that 75 level. So where do we go? We chose our own adventure. If we had the source code for our site and it was under active development, we could build this strict content security policy. And this path is easier and more solid than the whitelist approach. But if you don't have the source code to the site, you want to wrap a policy on some legacy thing, then go for the whitelist approach. And you saw how you could build that whitelist up iteratively by using a tool like report URI. Of course, every adventurer needs an inventory. So here are some tools that might help you. CSP Mitigator is a plugin for Chrome where you put in a policy, and as you browse around the site, it mimics what would happen. Evaluator is you paste in the policy and it tells you which bits of it are weak. These slides are available, so don't write too hurriedly. Reporturi.com is that tool that has the free plan. That's the Google site. And then the Mozilla Development Network pages on content security policy are actually quite good. I don't know if we still call it Mozilla Development Network, because now that Microsoft has put their documentation there as well, maybe it's Micro Mozilla, I don't know, whatever, MDN. Cool, so you've completed your quest and you've arrived at your destination. You have vanquished all the XSS that you know about, and you've fortified your site so that if an attacker gets cross-site scripting onto your site, it won't run. So in this talk, we've covered briefly what is XSS. We've covered the XSS parts of content security policy, the whitelist approach, the strict approach, and pointed out some tools. And you've got this list of the most important sites in your organization, and you're going to take that back to work, and you're going to start with number 1 and work your way down. So I think that's probably like the best thing that could happen. Cool, that's the end. Thank you very much.
Awesome, thank you, Kirk. We've got about 5 minutes for questions. Any? Yeah, well, all right. First one here.
Cool.
Yes,
yeah.
you.
Oh, okay, so the question was, when did support for this start coming in browsers? So I first gave a talk about content security policy in 2011, and I think it was just in Chrome then. Now it's in Chrome, Safari, and Mozilla Firefox. I mean, Chrome and Safari are the same thing, pretty much. And I don't think Edge and IE support it as well. You can go to caniuse.com, as always, every developer's favorite resource. So the other thing is that there's obviously multiple versions of content security policy, and for some reason this isn't showing level 3. Level 3, which is where you can do the strict dynamic, is just in the newer browsers. And then the bad thing as well, which I also didn't mention, is that if you give a content security policy to an old version of Chrome that kind of understood content security policy but implemented it wrong, then bad things happen. But because Chrome auto-updates, I don't know if that's a big issue, because that's like the 2011, 2012 versions of the browsers. Any more questions?
Awesome, next. Yep.
Why would you use a nonce instead of hashes?
Oh, cool. So the person up there asked, why would you use a nonce instead of hashes? So if you've looked at CSP, there's actually 2 ways you can mark your script tags. And I showed the nonce way on one of those slides, putting a nonce tag in there. You can also do a hash approach, which is where you basically take the contents of the script tag and then run I think it's an MD5 or a SHA-256 hash and put that value in. But that just seems like more work than a nonce. And also, if any bits inside here change, then you're going to have to be redoing the hashes. So I kind of like the nonces more, but you can use a hash approach, and you'll be able to see that if you follow the links.
Awesome. Oh, go again? Sure.
How about SRI?
Okay, so the question was, how about SRI, which I think is Silicon Research Institute? No, Sub-Resource Integrity. So content security policy does like a bunch of things, and Sub-Resource Integrity does like a little bit of stuff. So Sub-Resource Integrity, as I understand it, is when you refer to an external resource, you're making a hash for that JavaScript file, and the browser won't load it unless it matches the hash. So it's kind of complementary, but not exactly the same thing with content security policy, I guess. You're saying trust the stuff on my page, and sub-resource integrity is more about the contents on the other server. Yeah, I don't know. I don't know, I don't think that's as cool. I wouldn't do a talk on it.
Awesome. One more question? Yes?
Suppose I'm an attacker and I've got a stored XSS. Why not just put the my nonce template string? The web app will put it into the response, and then the reverse proxy will still template it out, won't it?
Okay, so the question is, if I've got an attacker with stored XSS that I can inject on the page, if I put the my nonce variable in there, why wouldn't it just get replaced? It's normally because on the server side, you do have a delineation between your code and the attacker's code. So you mentioned that it might run in a reverse proxy, but actually it would probably run on the same web server. So the attacker's variable would be like name or something like that. And it's going to get echoed in the page, but it's not going to echo the name and then process it again and expand the nonce. Because if you could do that, then attackers could just put any Java code or Ruby code or whatever, and it would run. So yeah, I guess if you're doing the nonce expansion in a separate layer, like in a proxy, like I was showing this morning, then you wouldn't be able to use this approach. Yeah.
Cool, that's all the questions we have time for. I'm sure Kirk's available if you'd like to talk to him more about it. And an excellent presentation, and it is available, or will be available on the OWASP site.
Cool, thank you for indulging me.
Thank you.